Welcome to the Slop Farm. Enjoy the video.
You start by confirming the object is actually a subspace. Make sure 0 is included and that sums and scalar multiples stay inside. Once done, pick the ambient basis. Often the standard basis simplifies work, and express each vector as a column of coordinates. Next, form a matrix whose columns are those coordinates. This is your working representation. You will now use row operations to reveal dependencies and the dimension, so get the matrix into a manipulable form right away. You perform Gaussian elimination to reduce the coordinate matrix to ref because pivot positions tell you which columns are independent. Then choose the original vectors corresponding to pivot columns as a basis. That gives you a minimal spanning set and the dimension. If you need a spanning set, make sure any removed vectors are linear combinations of the chosen basis. Otherwise, add independent vectors until they span. Throughout, track row operations so you can back-substitute coordinates reliably. You now solve for coefficients. Set up equations, a x equals b where columns of a are basis vectors and b is your target. Use the ref you computed to read solutions directly. If the system is consistent and the rank equals the number of basis vectors, the representation is unique. Reconstruct B from the coordinates to confirm. If inconsistencies or unexpected free variables appear, recheck your elimination steps and arithmetic. A single sign or pivot error often explains the.
Thanks for watching. Consider subscribing if we helped you today.